Hi everyone, and welcome to our video on proving trigonometric identities. So to prove an identity or to verify an identity, so they use those two phrases most of the time, it really is just a simplified problem. So you're going to choose one side and then you're going to simplify it as far as you can. And then hopefully it looks like the other side. If it doesn't, then that means choose the other side and simplify as far as you can. Okay, so for this first one, so to verify this identity, we're going to choose the left-hand side. So LHS is left-hand side. And then all we do is just write just the left-hand side. So we just rewrite it all by itself. And then now it's a simplified problem. So now we're just going to try to simplify this as far as possible. So proving something's an identity is really simplifying, like from these videos. Okay, so are these problems from previous videos? However, what's good is they're giving us the answer. Okay, so this left-hand side, they're saying it should equal this right-hand side. If it doesn't, then we messed up and we can go back and figure it out. Okay, so that's why these are better. These, they're not telling us the answer. We're hopefully just doing it the best we can and fingers crossed. But I mean, if you're sticking to your strategy with your algebra rules, then you should be good. Okay, so let's see how this works. So let's verify this. Okay, so all I did was rewrite it. But now I'm going to apply the reciprocal identity. So, or they might call that the quotient identity too sometimes. Okay, so this is cosine of theta over sine of theta. And then that is what I want. Oops, they're both squared though, because cotangent was squared. There we go. So cosine squared of theta over sine squared of theta minus cosine squared of theta over 1. And I'm just putting the 1 down there as a placeholder. Okay, so what we did on this step, so from this step to this step, we did the quotient identity. So I do want to just mention that just in case they say that. However, they should just call them the reciprocal every time. Reciprocal identity. Okay, so we did the reciprocal identity, and I'm just writing this to the side because sometimes when we're proving an identity, they want to know, well, how'd you do that? What'd you do from step to step? Okay, next step. I see I've got separate fractions, so I should get a common denominator. So that means this sine squared of theta would times the 1 right there. Okay, so those combine. And then this one multiplies that, top left, which isn't going to really change anything. But the sine squared of theta will multiply the top right. Okay, so I'm using my same strategy as before. So let's get a big fraction. We're saying cosine squared of theta would times 1. So let's just say cosine squared of theta. And then minus, well, cosine squared of theta is timesing the sine squared of theta. And then down below, sine squared of theta times 1 is still just sine squared of theta. Okay, so from this step to this step, we would probably just say simplify. Okay, so it's a rule with fractions, but nothing real special that's new, like with identities. Okay, but the next step. Okay, so we're looking at our numerator. There's nothing to combine. However, these two terms each have a cosine squared of theta in common. So we're going to factor that out. And that means we'll be left with in parentheses. So if we took cosine squared theta out, we'd be left with a 1 minus, and then we took cosine squared of theta out, so we're left with sine squared of theta. And then it's still over sine squared of theta. Okay, so from this step to this step, we factored. Okay, so we've got this. Okay, so now we're still looking at it and saying, well, what else can we do? Still thinking right here, this is what our answer hopefully will look like. So we're saying this is the answer. Okay, so we might need to mess with it in a second, but I think on this problem we can get there all the way. Okay, so let's continue. Well, you might recognize this one in the purple now. That's a Pythagorean identity. Okay, so just scroll back up. Scroll, scroll, scroll. There was our identities. It's one of our Pythagoreans. Okay, so whenever you have something squared, you want to think, is there an identity that I can use, a Pythagorean identity I can use? And yes. Okay, so our identity is cosine squared of theta is 1 minus sine squared of theta. Okay, so that is from this step to this step, we're doing Pythagorean's identity. And I'm abbreviating. Okay, so that means the blue cosine squared is still here, but I'm just changing it back to black ink. And then what was in the purple, we said, I'm just bolding in the black ink again, is cosine squared of theta. And then down below is sine squared of theta. Okay, so that identity is real nice in this case because it made this fraction all multiplication. So that means we can start to try to simplify or cancel. Again, look at our answer up here. Okay, so we know it should look something like that. And then we're saying, oh, look at this. Cosine squared of theta and sine squared of theta is cotangent squared of theta. So that's this part. And then our leftover part is there too. Looks like we got it. Okay, so but let's finalize it. So we've got one more step. That's cotangent squared theta. That was highlighted in yellow. And then cosine squared theta is still there. Okay, so that's, again, we did the reciprocal or quotient identity. Let's just say reciprocal this time. And then to fully finalize it, we're going to say, oh, that was equal to the right-hand side. We did it. We showed it. Okay, so we proved it. So that's how we verify these identities. Okay, so let's do this one too in the same video. So if you need to pause, do it. But let's break this one down too. All right, so we choose whichever side we want to. I chose the left-hand side on that video. I could have chosen the right-hand side. On this one, I think that's what I want to do. I'm going to choose the right-hand side in this video, or on this problem. And so I'm just going to rewrite out the right-hand side exactly as I see it. Okay, so that's always the first step, just rewriting it. And then again, I'm thinking this is the answer. I can hopefully get there all the way. So notice I'm not like moving things around left and right on our equation. I'm just choosing a single side and then I'm going to simplify. Okay, so verifying is different than solving. Okay, so don't use stuff that you would from solving. So don't say, oh, let me multiply that on over right away. No. That's not what we do on verify. So they follow a little different set of rules. So just choose a single side and then continue working on it. Okay, so I chose the right-hand side because it has cotangent and cosecant, and I know I can change those with reciprocals. The left-hand side is cosines. Those I usually don't want to mess with. So sines and cosines I like. The other four I can change to sines and cosines. Okay, so big parentheses. Cotangent of x is cosine of x over sine of x, plus cosecant of x is 1 over sine of x. And then it's all squared. And then look at this, we've got a common denominator, so I'm going to combine that right now into a single fraction. So I have cosine of x plus 1 over sine of x, all in parentheses, squared. Okay, and if they're asking, oh, how'd you go from this step to this step? You're saying reciprocal, identity, let's put, I'm abbreviating things. And if they said, oh, what'd you do here? Well, it was just algebra rules here. So they would probably just say, oh, it's just simplify. Okay, now, again, I'm kind of always peeking at my answer and saying, all right, look at my answer. 1 plus cosine of x. I have that already in my numerator. I'm going to rearrange it to really see it like that. Okay, but it's still in parentheses, still squared. So from this step to this step, I guess we did the commutative property. If they said, oh, what'd you do there? We might just be able to say simplify, but there it is officially, commutative property. We just move things around. Okay, and then this next step, so I'm going to use the rules for squaring. Remember, if you have a fraction and you're squaring it, the whole top gets squared and the whole bottom gets squared. Like that. Okay, so it looks something like that. Okay, so there we did just square. Okay, but let's rewrite it. Again, looking at my answer up here in the top left, I want 1 plus cosine of x. So I don't want to FOIL this. I want to just show what squaring does before the foiling. Let's just rewrite it. So we're expanding. And then the denominator, we probably rewrite it like that, sine squared of x. Okay, so it looks like I have part of my answer already. So I'm just going to highlight that and say I have that part. I want this 1 plus cosine of x, let's bold it. I want that to just go away. And then sine squared of x, I mean, I don't have that at all. I have 1 minus cosine of x. So this is where we go back to what I said in the last problem. If you have something that's squared, you're thinking Pythagorean identity. Okay, so this sine squared. So if you have something squared, you're thinking, is there a Pythagorean identity? Yes, there is. Okay, so our Pythagorean identity will tell us that sine squared of x is equal to 1 minus cosine squared of x. So let's rewrite that. Okay, so 1 plus cosine of x still, and 1 plus cosine of x still. And then now we are applying the Pythagorean identity. To our denominator, we're saying sine squared of x is 1 minus cosine squared of x. Okay, so we have that. Now, the reason we wanted to do that is because, again, this let's bold it again. I want that to go away entirely. And I wanted cosine down in a denominator. And so now I do have cosine, but it's to a square. Well, here's our other thing that we think of. If something is raised to a higher power, factor. So that's a special factoring. Let me scroll down. We're running low. I'm going to have to move it a little bit over. I think we'll be able to fit it on this. But we're going to factor that. So this is the difference of squares. Okay, so let me put a little cloud here. Remember, if you have something squared minus something squared, it is a minus b times a plus b. Or a squared minus b squared becomes that. So that denominator is going to follow that rule. So my whole numerator still is 1 plus cosine of x times 1 plus cosine of x. But I'm going to factor the denominator and say that that's the same thing as 1 minus cosine of x times 1 plus cosine of x. Okay, and you can double check with FOIL, it works. We are just using the difference of squares. We're just using that one. But double check, 1 times 1 is 1. We would have a positive cosine of x and a negative cosine of x, which would zero out. And then a negative cosine of x and a positive cosine of x would be negative cosine squared x. So it is a match. Okay, and then now we can say, well, what did we want? I'm going to keep my same yellow highlight. I wanted this, and I had it from my answer. Again, that highlighted yellow, I'm just matching this highlighted yellow. But now I've got a factored out expression. So that means everything's been multiplied. And that means I can cancel. Look at this. This 1 plus cosine of x and that 1 plus cosine of x would cancel each other out. And we're left with 1 plus cosine of x in the numerator over 1 minus cosine of x in the denominator. And that is the left-hand side that they said we should get. Okay, again, they're telling you the answer. How nice of them. Okay, so just to highlight, the 1 plus cosine of x, still the same yellow. And then, let me do green because I did pink earlier. 1 minus cosine of x there is this 1 minus cosine of x. So it's an exact match. Okay, so we did it. All right, so these problems, verify, they give you the answer. So again, they're being real nice. They're just saying, hey, there's the answer. Show us how to get there. Okay, and so when you do these problems, you got to show lots of steps. So you can't just say, oh, here's the right-hand side, and then in one step I have the left-hand side. No, we're not going to believe you. Okay, so you got to prove it. So lots of steps there to show the full process. Okay, so if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.